All right, everyone. Howdy, and welcome to the pre-show. As always, we're doing a little bit of this week's cyber news before we get going into the main material before 10 o'clock here Pacific time. If you're joining us early, thanks for joining us. If you're joining us later, thanks anyway. So this week there was a little bit of interesting ransomware news, which is what we're going to kick off with. There were more than two ransomware cases, I'm certain, but two that are worth mentioning here at the moment happened in the state of Louisiana and also in the Commonwealth of Virginia. Let's start with Virginia. The Fairfax County Public School System was the latest school district to be hit by a ransomware attack. Now, Fairfax County is a gigantic district. According to the Bleeping Computer Story, it has about 188,000 students. It's pretty big. It's on the outside. It's on the outskirts of Washington, D.C. It's part of the DMV, D.C., Maryland, Virginia area. So this is kind of a noticeable, a notorious place to hit if you're a ransomware attacker. And this was the Maze ransomware attacking group, which is of note for a couple of reasons. One, that group has been going after a number of large targets, including Canon, Xerox, LG, right? But if they're going after schools, that's kind of a turn for them. They also went after the city of Pensacola. So one of the things that often happens when you have a ransomware attack like this is that the report from the officials is very much like this was a very sophisticated attack and, the criminals were unstoppable. Okay, we don't want to victim blame, right? Obviously, it's terrible that a school district was hit. They're far from the first school district to be hit with ransomware, even a Maze ransomware. But the truth is that most of the time, ransomware gets in because of poorly configured networks. Now, this is where we don't want to blame the victims. I used to work in schools. I know what it's like to be a school IT administrator. It's a lot of work for not a lot of pay. IT pays pretty well generally, but if you're especially a public school employee or a public school district employee, you're taking a hit to do some good, right? And you have some job security. There's some other things, but the truth is that generally speaking, if you compare the technical sophistication to schools and school districts to what you would see, for example, in enterprise, it's lower for a lot of reasons, but primarily it's budgetary, right? They can't afford always to have the latest and the greatest. And so they have to make do with what they have. And then there's also sometimes, not always, a skills gap where you'll have people who, and this is especially true in private schools, you'll have people who kind of came up as being the teacher who was good with computers, right? And they ended up in a position of technical authority at a school. And that's not necessarily the best preparation for handling something like cybersecurity. And this is an ongoing problem for school districts. I've mentioned it before on the stream, but if you check out the K-12 Cybersecurity Resource Center on Twitter, they have an ongoing list and map of school districts that are hit with ransomware attacks and other sorts of cyber attacks. Okay, next up we have a ransomware attack in the U.S. District Court of Louisiana. So this is municipal. This is a government entity that was attacked with ransomware. Now, this was a pretty bog standard ransomware attack. Louisiana has had multiple issues with cybersecurity, if memory serves, and this is just kind of the latest one. Now, TrickBot is the method that was used to drop this ransomware, and TrickBot is kind of this evolving and constantly changing dropper for malware. Not sure if you Okay, it looks like we're back. Sorry about that. Not sure why that took place. But what were we talking about? We're talking about the Ryuk ransomware and the TrickBot dropper. This is a dropper that's been affecting quite a few organizations and different platforms as well. TrickBot is a problem not just for Windows but also for Mac devices. So definitely something to keep an eye on. I use a tool called Feedly to kind of collect all of my cybersecurity news in one place. And if you're interested in this sort of thing, it's kind of a great aggregator for cyber news. You can also set up Feedly for all kinds of different subjects, but that's kind of what I like to use it for. Okay, let's move on to the non-ransomware piece of cyber news. So you may have heard let me see, I'm getting some reports of some sound issues. Let's see if I can sort that out. Okay, let's see if that's any better. So you may have heard about the Giggle ransomware, which, nope, not ransomware. Giggle is an application that is supposed to be all female, and it's a social network and kind of community building application just for the term they use is females. So I'm going to go with their term for reasons that will become clear in a minute. This application, without getting too far down into the politics of it, is sometimes considered trans exclusionary. And so that was problematic when security researchers came to the developers of Giggle with security vulnerabilities that they discovered in the application. Very basic stuff, in fact, one of which we're going to cover today in the material. The response from Giggle was poor, to say the least. Without assigning too much blame in any one place yet, I just want to call out that this is one of the reasons why Twitter is so terrible for having conversations. It encourages extremism and it encourages, I would say, flippancy. But anyway, the co-founder and the CEO of Giggle kind of dismissed the claims of security vulnerabilities, said that there weren't any. And then, of course, the security researchers, after attempting disclosure and being rebuffed, decided to publish their findings. And sure enough, there were significant issues with the Giggle application. And one of the reasons why the Giggle CEO responded the way that she did is because when the researchers went to disclose the information, they mentioned the politics of the CEO and of the application as being problematic and something that they disagreed with. So it already put the CEO on a defensive footing. Not that I necessarily even disagree with that idea from the researchers. You know, trans inclusion is problematic, but again, I just think it goes to how poor Twitter is to have these conversations. It may not have even been possible to, call up somebody on the phone or something like that, but it just seems like disclosure is difficult in the best of circumstances, and I think everyone involved made it harder here. But if you are building an application and a security researcher comes to you trying to disclose a problem, take them seriously. Give them the time that they need to explain the problem to you, and they could be wrong. They could have missed something, or they could just be trying to, if you have a bug bounty program, score cheap bug bounty points. But in the event that they have found something, they know about it and you don't, that's knowledge that you're going to want. So you want to take them seriously. All right, it is 10:03, so we're going to finish up with This Week in Cyber and move on to the main material. Welcome back, folks, to Hack Summer. My name is Taggart. You can find me on Twitter there. Before we go any further, if you're enjoying what we're doing, we're coming to the end of this particular series, but if you're enjoying what we're doing on this channel, give us a thumbs up on the video, and if you haven't subscribed yet, feel free to click that subscribe button so that when we produce more content, you'll get it right in your feed. As Hack Summer comes to a close, I am definitely going to be doing more content along these lines in the future. We'll probably cover material like web technologies, things like that. So if you are enjoying what we're doing and you're finding value in it, yeah, go ahead and do a subscribe. That helps me out and helps other people find this material. So what are we doing? We're looking at the Python programming language. We are looking at cybersecurity, and we're looking at cybersecurity through the lens of Python, and vice versa. What we've been doing for the last couple of sessions is building a to-do app, a tasks app in Python, and we're building it in a client-server model. So we have to understand how to build the server side of it and how the data is going to be stored on the server, but we're also building the client, the command line interface that people can use to create tasks and view the tasks that they've created. So last time we kind of built out the server communication and got the client and the server to talk to each other. We built out subcommands for the command line interface to make it a little bit easier to create that data and work with that data. We're going to start talking about authentication today. And so far in our application, we haven't had any authentication whatsoever. We have had just kind of like, here's the tasks, and then the server just says, oh, okay, and saves the tasks or retrieves the tasks that you're asking for a given user. That's not sufficient, and as well, that's actually part of the vulnerability that Giggle had that was disclosed by the researchers this week. And we'll talk about what that looks like and how to remediate that vulnerability. But before we do that, we actually want to take a moment and begin refactoring some of our server code in particular to a different architecture. Refactoring is when we take the functioning code and change its shape for either maintainability or clarity, or sometimes to add functionality, but really refactoring is about the structure of the code more than it is the function. So we're going to do that today using object-oriented programming. But before we even do that, we have to learn a new Python trick. It's been a while since we've done that. We've been building this application, but we have to learn a new Python trick that I've been dying to teach you, and it's going to be really valuable for us moving forward. So let's get going. What we're going to do is we're going to learn about map and how it can help us with some of our more tedious iterative processes. All right, let's get coding. All right, I'm just going to kick off a quick Python REPL. We don't even need to worry about this one too much. We're not going to save it really. You can if you want, but this is different than the one that this is different than our task server and task client that we've been working with. So what we're going to do is we're going to play with map. And what does map do? Well, let's actually take a look at the Python documentation format. It's always kind of tough to find it. So let me show you how we might find this. So if we go to library reference, we go to built-in functions, and this is something you should be familiar with all of these, not necessarily at this point, but you want to know where to find these and kind of learn about them because they're really, really interesting. And we're going to use two of them today that we haven't seen before. The first one is map. Let's take a look at map. So what does it say? It takes two arguments, a function and an iterable. And we'll talk about this a little bit more, how we can do this, but returns an iterator that applies function to every item of iterable, yielding the results. Now, an iterator is a little bit tricky. We haven't played with iterators exactly. An iterator is something that produces items in sequence. So we can use them in for loops, but they themselves they're not sequences the way that we think of lists or tuples or strings. They are a different object in Python. And we can turn one of these into a list pretty easily. And so we'll see how that goes. All right, basic idea here. I'm just going to change this to map demo. Okay, so let's, I'm going to go ahead and make a set of, or a list of things. Let's go with, the Mercury astronauts. Why not? So, let's see if I can get them in order. Shepard, Grissom, Glenn, Scott Carpenter. I think next came Wally Schirra. Everyone forgets about Wally. Deke Slayton. How many do I have? 1, 2, 3, 4, 5, 6, and Gordon Cooper. Okay. Cool. So there's my Mercury. There's my Mercury 7. 3, 4, 5, 6, 7. Yep. Okay. These were the first Americans in space, by the way, in case anyone was curious. Okay, so we've got Shepard. We've got our Mercury 7. We're going to use map to do something to all of these. So if you remember, we have some cool string functions like capitalize, right? Or which gives us the first letter, and then we have upper, which is going to all caps it. So we can create a function that takes any given string and returns the string's upper representation. So let's do that. Just call it up, and it takes a string value, and then we just return string.upper. Super simple function, right? And it's so simple, in fact, that if there were a way to do it in one line, we could, and we'll talk about how to do that. Okay, so now we have Mercury, and then we're going to say Mercury cap is going to be the capitalized version. What we're going to do is we're going to use map. So as we saw, map takes 2 arguments. The first is a function, in our case up, and then it's going to be the next one is the iterables, or the sequence that we're going to apply that function to every element of. And in that case, or for us, that's going to be Mercury. So what's going to happen is map is going to go through every element in the Mercury list, right? All of these astronauts, and it's going to send each one of those in turn to the up function. And then it's going to, the result of this is going to be this iterator that contains all of the results of those function applications. So let's see what that looks like. So if I run this and then I ask for Mercury cap in my REPL, see how it says it's a map object, right? It's not super easy to use here. But watch this. If I use it in a loop for m in Mercury cap, if I print each one out in turn, it works just fine. But I can't look at it as easily as I could necessarily a list. The good news is that those map objects I can easily convert into a list the way that we've converted strings to integers or integers to strings in the past. So if I use a list and then that map object that we have, that Mercury cap, oh, it exhausted itself. Sorry, I have to not do that. Yeah, iterators run out. They're like cassette tapes. They're like old VHS tapes, right? They have an end, and then you have to rewind them. File buffers are like that too, where you read through them and then you're at the end of the pointer. Okay, let's try that again. So if I do list Mercury cap, yeah. So see how now I have all of them because I haven't iterated through them yet. Just for a little bit more clarity on what's going on here, another built-in function is next. And what next does is it retrieves the next item from an iterator by calling it has a built-in magic function, just like Init with double underscores, by calling its next function. So to show you that in practice, so we've got Mercury cap, right? And it's a map object. If I call next on Mercury cap, what? Let's rerun it. There we go. Oh, because even sending it to the list exhausts the iterator. Good to know. See that? Next. Now, before we exhaust the iterator, let's rather than nexting it, let's list. Now, what should happen is we're going to get Scott Carpenter on, but we're not going to have Alan Shepard, Gus Grissom, or John Glenn in there. Yep. Did you spot my mistake? I forgot a comma. So that is how map works. It takes that function, right? It applies it to every element, and then it gives us an iterator that has all of the results. Now, I will say that generally I don't use the iterator. I mean, I can, but very often the whole point is that I'm trying to do something to a whole list, so I have another list because I want to store the list or something else like that. So if I don't need to loop through it, I just need to store the list. I will convert it like so. I will just right away convert the map object into a list. At which point now when I ask for Mercury cap, right, now I have the list, and it's not going to exhaust, it's not going to do anything weird. I just have the list. Now, as we said, this up function is really simple, and often that's what you're doing, right? When you have these lists that you're mapping a function onto, you could imagine something like, let's do a very simple list of numbers, right? I'm not even going to line break this, where it's just like 1, 2, 3, 4, 5. By the way, if you're thinking cleverly, you would know that I don't even have to do this manually. I could just say list of a range of 1 to like 6, right? Which would give me the same thing. And just to prove that point, if I ask for my ends now, you see I've got 1, 2, 3, 4, 5. So I don't have to manually do that stuff. I can use Python's built-ins to help me out there. But let's say I wanted to, I don't know, square all of them, right? Well, remember that we can do squaring. We can do exponentiation with the 2 asterisks. So if I do 2 asterisk, actually 2 is a bad one to do. 3 asterisk 2, it's squared to 9. So what I need is, I need to like, if I want to square them, what I need to do is I need to map a function that squares everything. Now I could make a square function that like returns the n asterisk 2, but it's kind of clunky to do that, right? So because it's so quick. Python has support for something called a lambda. This is called a lambda, like the Greek letter, because of the lambda calculus, which is a kind of a mathematical theory branch that I encourage you to look up. It also has a lot to do with another programming language that I love dearly called Haskell. But at any rate, lambdas are in Python, lambda, they are inline mini functions that we can write when we need to use a function somewhere. So lambda and then the colon, and then what I do, lambda and then the argument that I would give it. So in this case, the n, and then colon, and then the expression that is going to return a value. So I don't say return, but I write the expression, and it's got to be a quick expression, basically a one-liner, that is going to return the value. So if I want to square these things, I would say n asterisk asterisk 2. That right here is the function that I am going to use. And then, comma, now you can see that I'm on my second argument for map is going to be iterables. So let's do it for n's, right? And now let's just convert that whole thing to a list so we have easy visibility on it. So I've got this lambda. This is the part that's new here that we haven't seen. And what we're doing is we're just defining a mini function here. This is like def, and then we don't use parentheses for lambdas, but we do have the argument that it's taking, right? And then a colon, and then we do the expression that returns the value. Okay, let's run this. And then if we ask for n's squared, so it is successfully working with that lambda function. This is really, really fun if I need really, really quick application of a function using map. There is also, I will tell you, there's another function, built-in function like map, called filter, that does something similar, except that it returns an iterator where only the elements of the iterable that return true for the function are in the result. So real quick on that, let's say I had, so evens, right, is going to be list map, the same kind of construction, lambda n, and we're going to just check for evenness. How do we do that? Well, if you remember, we have that modulo operator that does integer division. So we do n mod 2 equals 0. And then we're going to give that to the n's. Now remember, this statement right here is going to evaluate to either true or false, right? N mod 2 is equivalent to 0, is either going to be true or false, which means the this should be filter. Filter is going to take this function, run it against every element of n's, and for every element that it returns true, it's going to add it to the evens, first filter object, but we're converting it into a list, so then we have ourselves an evens list. Let's run that and see what happens. Yep, and I just got the even numbers in my list. So it's very, very handy for those. We've done so many for loops that do this kind of thing, right? It takes a condition, checks, and then if so, we append it to a new list. We even have that in our server code, right? We don't need to do it that way. We can do it this way. And that's a stylistic difference, to be honest with you. A lot of people find this confusing. This is a very functional approach to writing code. I prefer it. I think it's more readable, and I think it's a little bit more elegant rather than for looping all over the place. It also, because it's tighter, has less room for error. Okay, with the map and filter conversation out of the way, we're ready to dive in and start refactoring our server code. Yeah. Okay. So the first thing that we're going to do over in the server code is we're going to start changing up our server lib a little bit. Notice that first of all, we're only dealing with tasks at the moment. That's okay, but we can do better. And in fact, we're going to have to, because we're going to be storing users, right? We're not dealing with users yet, and we have to. The other thing is, I want you to take a look at the way that we've thought about and constructed these functions so far. Just add task, get user tasks, save tasks. When you start writing functions this way, I mean, you can name them however you want, but when you start writing functions this way, you're really, what you should be thinking is, I'm talking about users a lot, I'm talking about tasks a lot. I wonder if there's another way to build this code that makes a little bit more sense. And in our case, that is definitely going to be object-oriented. So what we want to do is we want to create two classes, a class for tasks and a class for users. What does that look like? And why would we do it? So first of all, the reason we're going to do it is all of the code for the tasks is going to be contained within the tasks class, much like we did before when we started doing some object-oriented programming, where we did it for our game and some other stuff in our RPS session. It's going to really help organize our code. So and it's also going to give us some guarantees when we work with data. So one of the challenges we have is that we have this JSON data coming in from the client, right? If we think about our diagram, the data coming from the client here is all JSON, right? But there's no guarantee at that point that the data is properly shaped, right? That it has a good, task title or description or whatever else. And the same thing is true for users. There's no guarantee of that. It's just raw JSON data. Well, by translating that into a class that we work with in Python rather than just raw JSON or even a raw dict, we have a little bit more control over how we're shaping that data and what happens once we receive it. Let's start building these classes, and I think it'll make a little bit more sense once we do. So let's start with the user class. It's a little bit shorter. They're both kind of equal length. So just kidding. We're going to start with the task class because we already have the task stuff going on. All right. So let's just go ahead and do class task to start. And we're going to actually indent this tasks file inside the class because now it's no longer a global, it's part of the task class, right? It's attached to that. So if I ask, you can even see here, if I ask for task now dot, thanks autocomplete, not figuring it out yet, but it will be in there that the way we would access that variable, well, it's a constant really, is task dot tasks file. And that's kind of the model that we're going to follow for the rest of this as well. Let's go ahead and translate this right here into a new class method to load the data. Let's also create a variable called tasks inside of the class, because now we can store all of the loaded tasks in the class rather than just kind of globally with this right here. So it's gonna be a little bit different. What we're doing right now in the app is we're doing this for whenever we do a thing, right, we're like loading the data, and we don't have to do that anymore. What we're going to do is we're going to keep it in the tasks class and kind of initialize it when the application starts. So let's go ahead and make a class method. If you remember, we use the class method decorator to do so. And then we just write our function. In this case, we're going to do load. Now, load takes, because it's a class method, it takes the first argument is the class itself, which I like to shorten as CLS. And that's all it takes in this case. This is where we take this try except here. And try to indent this. Okay. And we have to refactor this a little bit because now that it's inside of a class method, tasks file actually refers to cls.tasks file. Right? That's where it lives. It's inside the class. And then we're going to kind of redo this. Task data is equal to json.load from the file. So this is the raw data. But the reason why that's not actually going to be what the tasks are, you'll see in a second, is we're going to turn each one of those raw JSON objects into a task object when we load it into our application. Now, the trick is we haven't yet built the init for that. So let's kind of call our shot, and then we'll go write the init. So cls.tasks, remember that we have this tasks variable up here where we're going to store everything. It initializes an empty list, but when we load, we're actually getting the data from the stored file. The result is going to be a map. That's why we went to the trouble. Now we could do this with a for loop. We like for t in task data and then, tasks.append. But look at how clean this is going to be. So we know that we're going to map the constructor for the task object, which we can invoke just with the capital T task. Because remember, when we make a new object, we say like, if we said t equals task and then we send it some data, that would be like invoking the constructor. So we can work it the same way in here, where we send it the constructor using the capital T task for the class. And then what are we mapping over? We're mapping over the task data. And we don't want a map object. We actually want a list of those things. So now we'll have a list of task objects in our tasks variable rather than raw dictionaries. Now, in order for us to really use this, we have to create the init, the constructor for the class. Let's go ahead and do that. Now, what we want to do, we've seen kind of before where we like send a bunch of different arguments into the init, and we do like self.username or like self.this, self.that becomes each property of the object. Well, because we're going to be getting JSON from the client anyway, we're going to just send the whole dictionary into the constructor and access them internally. So imagine this data as a dictionary full of the stuff that we need. So the class right now has a username, which matches with the user's username for now. And what else does it have? Remember, it has a title. I can spell description, or I can just let Replit do it for me. Now, I said that one of the reasons we like to do this is that we get some guarantees about the data when we do it. At the moment, we're just kind of naively importing all of these string values in here. But because we're working in Python this way, rather than just with JSON, you could imagine that we're actually translating this date string into a proper date object in Python, which gives us a lot more power. Like we could add days, we could check time zones, whatever we wanted to do. The same thing with descriptions or titles if we wanted to. Like we have a lot more power with it when it's built in this way. It's also going to be easier to access because, again, we're going to have this dot notation where we don't have to use this key-based indexing. We can say like task.title. Now there's one extra one that we're going to build in here. Now we've seen that a lot of times objects in Python have these magic functions like double underscore init, or we just saw in next, we saw that there's a built-in underscore next for things that are iterators. Well, there is also a magic, there's a magic property called dict, much like we did for stir, except this is a property, not a method, so it's not a function. If we make this property, if we define this, it gives us a way of returning a dictionary representation of the object really, really easily. And that's going to help us out in the future when we have to translate this thing back to JSON to send it off to the client. So let's just go ahead and write it right now, where this is how we translate back from the Python object into a dictionary. Username, self.username, title, self.title, description, self.description, and due dates. I want to call it out right now. Again, we're just using strings, but date objects in Python can get really complicated, and so it's of value for us to have a really easy way of translating between Python date objects and the string values that we have to send to the client, and vice versa. I don't think we're going to touch on that too much during this course, but dates in programming languages, dates and times are a massive pain. They really require careful thinking about how we're going to handle them. But for now, self.dueDate. Okay. This might seem a little crazy, but the reason we're doing it is allowing us to have more control over the data as it comes into us. Now we have a couple of other functions down here, right? And we're going to refactor these into class methods as well. And as we do that, you're going to see that we don't need some of this extra stuff. I'm going to tell you right now that when we redo this refactoring, the make response, the server stuff that we're doing, is going to come right out. This make response is only going to happen over in the actual app.py. The class is not going to deal with web stuff. It's just going to deal with the data. So we're going to actually remove this import. And the only thing we're importing is JSON. Let's go ahead and let's start with save. Let's do this first one. So I like to put all of my class methods above my constructor. So we'll do it like this. Class method. And then it's in task already. So this is redundant. I can just call this save. And that's why if you start writing a bunch of functions that way, it's a hint to you that what you're really doing is object-oriented programming. You just don't know it yet. And you gotta refactor it into a proper class. You don't have to, but it's a good idea. So what are we going to do? Basically, we're going to do the same thing, except that, remember, it's a class method, so it takes CLS as its first argument. And then, again, it's cls.tasks file, and we're writing to it. Now, this is where it gets a little bit more interesting. Remember that our tasks, when we load them up with load, are not dictionaries anymore. They are task objects. If I try to write a task object out to JSON with json.dump, it ain't gonna work. I have to translate it back into a dictionary in order to write it. Luckily, I have an easy way of doing so. Just like the next function invokes the magic next double underscore next function inside of a class, there's another built-in function called vars that returns the dict attribute. So that's going to help us out here by, I'm going to just close this demo. I don't need it anymore. That's going to help us out right here. So we'll do this in 2 steps. Let's say dict tasks equals list map. And what are we mapping? We're going to map vars, the built-in vars function, onto the tasks list that is built into the class, that's stored in the class. And then we can do this. We're going to dump dict tasks into the file, and we're going to do the indent for pretty printing. So now we have our save. Let's see if we can handle add. One more thing we want to do with save. We want to understand from the server side, we want to understand whether the save succeeded or failed. So what we're going to do is we're going to wrap all this into a try and accept. Let's actually do it in here. So try, and then we're going to attempt all this. And then at the very end of all of our listing and mapping and all of that, we're going to return just a true that we can use to check if it was successful. And then if something goes wrong, we're going to return false. Okay. Then let's do add. So add is going to look way different. Oops. And again, that class is coming in, but add is a little different because it also has an incoming task. This is not creating a new task. Remember that. So this thing coming in is not a dictionary. It's already a task object. So our job here is to add. We're just going to delete this because none of it is relevant anymore. So again, we're going to do the same sort of thing. We're going to try to append this new task. And then return true. That's it. And then accept, return false. So we have add, save, load. We haven't done edit or update or delete or anything yet, but we have a good structure here. Now the last one we're going to do is get user tasks, which is again a class method. So not a whole lot of object methods, right? Just a lot of class methods, and that's because so much is about all of the stuff in the class rather than the instance. So let's do def get user tasks. That one, the function name still makes sense. So again, class, and then we're going to do it by username, right? Because that's the property that both the user and the task have in common at the moment. Now we're going to, if you look at what we did before, we have this 14 tasks. Now we know another way of doing it, right? Now we have that filter, so it's a lot cleaner. we could do it with a for loop, and we'll do it that way first. So let's start with user tasks equals empty list, and then for t in cls.tasks, because we have it in our tasks variable there. If t.username, right, equals username, user tasks dot append t. Now we might actually want to say like translate it into a dictionary, or sorry, not dict, vars t. We might actually want to do that because presumably this is what we're going to be sending back to the client. Okay, so and then once we're done, we just return user tasks. Right, that's one way to do it. But we can also do it with a filter. If we do it with a filter, it looks much, much different. So we could say user tasks equals filter lambda t dot username equals username. This is getting very long. cls.tasks. So what we're doing here is we're filtering out, we're filtering only for the tasks in cls.tasks where the username matches what we're looking for. Now these are still task objects. So we could say from there we could actually do a map where we map vars onto user tasks, and that's actually what we return. And if we wanted to, we could do it as a list, right? So list map var user tasks. So same thing, 2 lines of code. Now, I find this cleaner and clearer, but maybe it's not. I think that really depends on your audience, and if you're and other programmers that you work with, if they're used to working in a functional style. I felt it was important to show you this because honestly, this is the way that I write Python these days, and it's quick, it's clean. But both of these have the same result. And the performance difference is not, like the speed at which they do it is not so different that you really need to care. So this is very, very clean and elegant, but this is maybe simpler to read, depending on what you want to do. They'll both do the same thing. So we'll keep it with the iterative style for now, just for kind of clarity's sake. But I recommend getting comfortable with filter and map. Okay, so that's our tasks class, our task class. All right, let's go make our user class. Now that we have to store users, we have to care about users. At least a little bit. We're developers, we should care about users. Now this time, let's start with the constructor. because this is kind of a new idea for us. Init self data. It's going to do the same thing, take raw JSON. So kind of what we need to do then is we have to provide a registration function in the app, which we'll do, that takes kind of a new user from the client and registers them. Okay, so self.username equals data username. Self.first name self.last name and then here's the controversial part. It's not controversial, it's just bad, but we're leaving it in there for a reason. And we're going to do that same thing that we did before, where we make that _dict property, and we'll do this, right? To represent it as I forgot. The order doesn't actually matter. It just matters to me that they're in the same order. It would kind of drive me crazy if I did these in a different order. Okay, there's our constructor. It's not complicated. And there's more that we should do with this part especially, but for now it's okay. Now, while we're here, let's make some class methods. Many of them are going to look very, very similar. In fact, let's actually just copy the load, save, and add. So much of this is going to be almost identical, right? Which is another hint, actually, that we could write a single. We haven't talked about this, but classes can inherit from other classes. So you can have like parents and children, and they can share methods and properties. We're not going to get into that, but largely what that would mean is that we wouldn't have to rewrite all of this. But for now, it's fine. And unfortunately, Replit doesn't have a really good find and replace. At least I don't think it does. Oh man, yeah, it does. Okay. Oh, awesome. Okay, I can do that cool thing. I love this. So I'm gonna look for every task, word task in here with Control D. So great. I need it to be case sensitive, though. This is such a fun trick. Control D, do. Yep. And then we're just gonna do this. Look at how many cursors I have. Super handy. Oh, I forgot this one. That's okay. There is a programming rule we've talked about before about DRY. Don't repeat yourself. And we are repeating ourselves a little bit here, but it's for good reason. Usually the rule that I have is the rule of 3, where if I have to repeat myself 3 times, then I'm going to go and abstract it out into a thing I don't have to repeat. So for example, if I had a third class here, in addition to user and task, that basically had all the same stuff. I might create a parent object, a parent class that has load, save, and add and delete methods that were a little bit more abstracted, so I could use it for both at the same time. For now, though, I think we're good. Now, the user has a couple of other methods, right, that the task does not. For example, authenticate. Now, authenticate could live as a authenticate could live as a as an object method. Actually, let's do it that way. I wrote it originally as a class method, but now that I'm thinking about it, it makes more sense as an object method. So authenticate. What we're going to do is take self, and then no, you know what? I'm sorry. It does have to be a class method. Let's think this through. Why does that matter? Okay, so authentication is going to go kind of from the command line, right? So what are we passing? We're passing the username and the password. So we have, when we come in and we authenticate, we have a username and a bunch of users and a password, which means we don't yet have a specific user object found, right? We don't have that yet. So it doesn't make any sense to have that attached to the specific object. So instead, we're going to make another class method here called authenticate. Takes the class, and then it takes the given username and takes the given password, the stuff that we're going to send from the client or receive from the client, since we're on the server right now. Now let's go find the right user. Let's also write a function to get the user. This is another one where you might want to use a filter. But in this case, I'm going to use a for loop. For you in cls.users, if you dot username equals username, return you. Then, if it doesn't, if we don't find anything, if we get out of that for loop and nothing happens, we're just going to return none. So we're going to do found user equals cls.getUser for the username. Then we're going to check to see if we found it, because none will return false if found user. We're going to do return found user dot password equals password. Now, still a lot of security problems here, but at least now we're checking to see if the provided password from the client matches what we have stored for the user. And again, this is returning true or false, right? If they match, then it's going to return true. If they don't, it's going to return false. All right. It's taken a lot of time, but we've refactored this into nice classes that'll be really handy. Now, let's talk a little bit about how we're going to refactor the app itself to take advantage of these classes. the first thing is, now that we have those load methods inside of the classes, we're going to take advantage of them to load. As soon as the app starts, we're going to load the data straight away. So let's do that. We're going to just call task.load and user.load. That is going to load the data from what is stored. Now, in the user's case, there is no JSON yet, but that's okay, because if you remember, we put that in a try and accept. So it'll come into an empty list, and that's fine. The next time we get a user registered, it'll save out. Now, we have this route for tasks. We have to clean this up, right? We can no longer, one of the problems we have with the server right now is that it's just giving away tasks to any user. This, if there's a U. So what if we had a new task? We'll call this, I'm just making the task raw, secret task. And the username was like Bob. Okay. Let's go back to our app. And we have to refactor this get user tasks, right? Because now we have task dot. Seriously? Get user tasks. That's annoying. I'm going to open up the server lib in a new tab. There we go. So we have both of them open at the same time. So remember, we have get user tasks, right? And it's returning the vars, meaning we have the dictionary. So that's all good. JSON.dump_s for that. Okay, let's run just this. And let's attempt, let me open this up in a new tab. /tasks and u equals empty taggart. All right, looks like we might have a bug here, but let's just try this out. U equals Bob. Still an empty list. Tasks, stack it, user tasks. Let's stop this and print out. Tasks, get user tasks. Just debug this real quick to make sure that we're returning the right thing. And then that'll also clean this up a little bit. Okay, so problem is over here in the server lib. T.username. Everything okay with our tasks? Oh, you know what? That's probably why. Because we had that empty, yep. We had that empty object in there, which was messing up our map of creating all of the tasks. That's actually a really important point, right? The class is going to control our data both ways. Now we could have put a safety in there if we wanted to just kind of skip it. But I think it was useful to see that happen. Now, finally that we have this thing running, watch this. This is finally our exploitation. This is an actual security vulnerability that is known. And it's known as an IDOR vulnerability, or insecure direct object reference. Oh man, so great. So OWASP, the Open Web Application Security Project, has a great bit of information on IDOR. Let's also look at Portswigger, which is a security company, talk about what they are. So it's a type of access control that arises when an application uses applied input to access objects directly, which is exactly what we're doing, right? You see here that we're just saying, hey, go get the thing for Bob, get that stuff. And the problem is, sometimes you'll see it like, even if the user IDs are like sequential, if they're like IDs 1, 2, 3, 4, you can just guess those, right? It's a real problem. But even if they're usernames, right? Especially if they're really simple usernames, there are lists. We've played with them. Remember when we played with sec lists, right? We played with the passwords, but the sec lists repository, and there are many different repositories or collections like this, have look at this, have collections of names, just gigantic lists of names. So if I'm providing a way for somebody to just access this stuff, they can run a brute force and they're probably going to get data back, So, or if they know something about you and they know a username that you've used someplace else and they can try to guess it in this application, that's the ball game. So we have introduced an IDOR reference by design. We did it intentionally to talk about it, but this is a real problem, right? We need to be able to say, okay, you can't just have a user's data because you asked for it. You got to prove that you are that person. We have to handle that as well. So the last bit we're going to do, because we've covered quite a bit today, the last thing we're going to do is we're going to require that the user provides the password. Now, that also means we have to store the user data. So kind of two steps here. The first is we're going to be able to register users, and then we're going to require authentication to get the tasks. Okay, so up first, let's create a users route now that we're dealing with users. So let's do app.route/users, and the methods for the moment that we're going to accept are going to be get and post. We have to be able to create and get users, but mainly we're going to be creating users. And then we'll make the users router. If request dot method equals post. Then we're going to say data equals request dot JSON. We're pulling that data in. Now this is where we finally get to use our user class. So new user equals user data. Now we could actually wrap this in a try except, and in fact should, but for now it's okay. this is where the methods that we just spent all that time building really come in handy. Really come in handy. Let's change this over to the server lib again. Watch this. User.add new user and user.save. So we're using the class ability to save out all of the data. So every time we create a new user, we're making sure we're saving it. Now, generally you'll see the save for things like this built into the object itself, but that's because we're kind of cheating with the kind of database that we're using. We're not using a proper database. We're using a JSON file, so it's a little bit less flexible. Okay, if all of this works, then we're going to return make response user created and give it a 200. Let's wrap this in a try except. And in this case, yeah. We'll give it a 500. And we can make, kind of more specific exceptions if there was like a password missing or whatever. And we could even use our class to raise those specific exceptions. But for now, this is sufficient. And this is all inside if the request method is post. So that'll do for us for the for the user creation. Now we have to hop on over to the client. And what we're going to do is we're going to create a new function that is going to be a little invisible to the user, but that we call from init. If you remember, we did init. It configures the client, right, with all this stuff. Well, the one thing that we haven't done is we haven't sent any of that user information to the server. So we're going to do that as soon as the init finishes. So we're going to write a new function called register. Now remember that the client is still a little bit more function-based than class-based. And that's okay for what we're doing here. Just the way that it's built, the client is just a fundamentally different architecture than the server because we're not dealing with data the same way. You could do this class-based, but this is pretty straightforward for now. So we're going to do the same thing we've done before, which is load the config, right? Because this doesn't run constantly the way the server does. So we're getting the config every time we need it. So if the config file exists, then we're going to create our, not a list, dict. We're going to create our data that we're going to send off to the server. Right, we're saving all that data locally. So we're producing it to send off to the server. Okay. Now we've got ourselves a data. Let's also finish up this if else. So if there is no else, then we're going to print no config found, run task client init. Okay, but if there is configuration and we're able to load all this data, we got to send it. So we're going to build the URL first. So we have the base, we have the config server URL. We're storing that, but then we need to add to it. So we're going to just do /users, and then we're going to send it off with the requests library. So r equals requests.post. Send it to the URL, and then the JSON equals the data. And then we're going to check if r.status code equals 200. We're going to print user registered. And if it isn't, we're going to print the text, whatever the error is from the response. Now we have this cool register function, which is going to send the data to the server. We need to kick it off. So we're going to do that from our init. And it's literally just going to be right after the write to the config file, right? So say print registering with server and call register. So let's do that. Let's do Python 3 task client.py. Sorry. Oh yeah. Task client.py. Let's rerun init just for the whole experience. Taggart, Taggart, password 123, and then the server URL I have here. Okay. Nothing happened because I didn't restart the server. It's like 404, meaning not found. Why? Oh, because I hadn't restarted the server since I added all that code. Let's try that one more time. Back over here, rerun init. Although that, sorry, that was really dumb. I just said r.text, I didn't say print. I was like, why didn't I get an error message? Because I didn't use print. Let's try that one more time. Yep. Hey, user registered. Okay, so let's see what happened over on the server. We got it. And if we look, now there's a users.json. This is really bad. We'll talk about next time why this is so bad, but this is bad. You don't want to store unencrypted passwords. But hey, we're storing users now, and we have a password that we can check, which means we can go back and finally fix our tasks route for getting tasks. What we're going to do is we're going to require a separate argument in the URL. This is also an issue, but for now it's fine. So we're also going to have a password component to it, and so it isn't enough to just provide the username, right? Which is what our IDOR vulnerability was. We now have to have a password. So let's actually, let's put this down in we're going to change up this a little bit. Yeah, so we're going to remove instead it's going to be else. So we're handling the post request in there, and then we're going to handle the get, and then inside of that we're going to do username equals request. Oh, there it is. I thought I had cut it. So we're getting our user from the U, and then what I'm basically saying is we're going to also say and p equals and then whatever the password is. So we're going to be sending it that way to get the tasks for the user. So we're going to check first if user.authenticate username, password. Then we can say all this stuff, right? Being inconsistent with my variable names, let's fix that. Very good. And then we're going to return make response of the JSON dump s user tasks, and this line is getting long. And a response code of 200. If that isn't true, we're going to return a make response of authentication failed and 403. That's got to be a tuple. Okay. And it's going to be, at this point, helpful if you review HTTP error codes. Just something to think about. So 400 is bad request, 403 is forbidden. 401, oh, I should be doing 401, unauthorized. Yep, that's why we have these codes, to indicate what kind of problem there is. So that's actually 401. Okay. That handles the getting of tasks with authentication. Now, how do we post tasks with authentication? This is a little bit different because we can send the password in the post request. We don't have to send it in the URL when we're doing a post. So that's what we're going to do. And for that, we're going to say username equals data, username, password equals data, password. And kind of the same thing where we do if user.authenticate, username, password, then new task equals task, and we send all of the data over. Even though it has the username and password in there, we don't use it in the constructor, so it's fine. It still has the title, description, due date, all that other stuff. We do use the username, but we don't use the password. So we send it over to task to construct the task, and then we task.add new task, and then we task.save to save them all out. Then we do return make response task created. That's a code of 200. Else we return the make response again, but actually we can just copy this. Same thing. Yep. Okay, I'm gonna restart the server here. And very quickly, we'll kind of close it after this, but you can see now if I ask for empty taggart, well, I get an error. Get user takes one positional argument, but two are given. Get user. Where's my bug? Oh, very dumb. Forgot the built-in CLS argument in my function. That happens all the time. Oh, let's try that again. Okay, I'm getting an authentication failed. That's great news because I'm not sending the password. Let's just manually send the password now. Okay, so now I have to send the right password. Let's send the wrong password. Still get authentication failed, right? Because it's checking to make sure that the provided password matches the one that's saved. But if I send everything right, then I get my data back. So very, very last thing we're going to do is we're going to update the client to take advantage of this. So to get the tasks, this is actually super simple. All we have to do is modify our URL string here to say end p equals, and then add one more thing here to our format, config password. And just to prove that it still works, let's go ahead and ask for our tasks, and it still works. So it's authenticating with stored creds, which is something we'll deal with next time, and then getting it. Whew, okay, that was quite a bit, wasn't it? But the good news is we were able to take care of kind of all of it in terms of addressing the IDOR vulnerability and then exploiting it and then remediating it. remediating it. IDOR is really, really common in application misconfigurations, so it's something to know about when you're developing your application. It's important to do good authentication. Now, we haven't solved every security vulnerability in our app yet. There's still more to cover, and we'll do that next time, which is going to be kind of where we put our finishing touches on the task app and kind of button it up. We'll have one more session after that, which is largely going to be about where to go next in your Python programming journey or your programming journey in general. But for now, we're pretty much getting to the end of our PyTasks application. But we will be addressing next time password storage and transmission, where what we're doing right now is not best practices by any means. So we'll be we'll be tightening that up next time. So that's going to about do it for this episode of Hack Summer. Thank you so much for joining us. If you're enjoying what we're doing here and you want to give back, I encourage you to check out Human IT. They are a nonprofit organization that is providing low-cost internet connections and computing devices to families in need. We're in the full swing of the school year here in the United States, and there are still families who definitely do not have adequate access to the computing technology they need in order for their kids to go to school. So if you want to help out, check out Human IT at human-i-t.org, and you can either provide lightly used devices or you can contribute financially. So that's going to do it until next week when we tighten up PyTasks and kind of close out this capstone project for Hack Summer. Thanks so much for joining us, and we'll see you next time.